signal technologies, and we start our session in 11 and ends half past 12. I'll be the chairman of this session. My name is Nebojša Raičević from the University of Niš, Serbia. And we have five papers, and I suppose that we can start with the first presentation. The first paper is under the title Concept of Speaking Age Estimation using Neural Networks to Reduce Child Grooming. Authors are Renát.
Yes, Renát.
Renát Haluška, Monika, Badovská, Matúš, Pleva. All of authors are from Slovakia.
Yeah.
The presenter is Renát Haluška.
Thank you, Mr. Chairman, for introduction. So I'm Renát Haluška from Technical University of Košice. I would like to introduce our works or our project, maybe. Concept of speaker age estimation using neural networks to reduce child grooming. Maybe about me more. I'm also from Department of Electronics and Multimedia Communications in Košice. Main building of university, so feel free to come visit us. Also text me, mail if you want to visit the university. You are warmly welcome. So what is the grooming? Well, I think that everybody knows the story behind that. Some teenage girl starting chatting with some guy on the other site, yeah, and it's very good for her. And after the time, yeah, send me some pic, yeah, and go on, and from texting could be sexting, and that's the problem, because there are many stories that this teenager girl, mostly girls, but there are some cases that also was boys, abused sexually. They don't know what to do. Yeah, they afraid to come to parents and say something that I sent something that it's not very good. Yeah, and in some cases also it's ended with suicide, and it's not good for us, everybody's here. So me and my colleagues from Technical University started a project with also participant from Norway University NTNU, and started this project small. You can also open a website if you want to learn kids or teenagers, girls or boys against to grooming. Yeah, we'll upload it more material, some posters, so you can be downloaded after some time. And there is also the video. It's in Slovak language, but with English subtitles, where the young 25 girl started chatting on some social network, and after 2 hours, she had in portfolio that she's 12, yeah, like fake, and after 2 hours she had 10 guys that I want texting and so on. So it's a common problem of this era of the internet. This is the picture we were to high schools. The last one is on university. And we have some presentation about this topic that be careful, kids. Yeah, that could be the problem. And sometimes you don't know who is on the other side of the internet. So me and my students started to prepare some demo systems. Well, it looks like a little bit, from social network to prepare our detection system. That when I spoke with young people, they told me that sometimes they don't want to text somebody, but instead of send some voice message. It's very famous from 13 to 18 teens. Yeah. So our idea is to detect age of the guy on the on the other side, if it's actually the age which is set in his profile. It's not only for maybe the teenage boy or girl which sending voice, but it could be also that, okay, there's the problem, maybe can be sent it to parents that your kids is texting with somebody that's not looks like that could be the good guy. Yeah. Also, yeah, we can, unfortunately, it's in Slovak language. Yeah. We see that the age is 16, but after detection that, okay, the user, the estimation age is plus 30, for example. Yeah, it's only demo, but we are still working on it. We prepared datasets with Slovak speakers, or we used dataset Common Voice with more than 9,000 audio recording, and we split to these recordings to age generation, yeah, from teens to 80s to 8 categories. For detection, we use 2 neural networks, deep neural networks and convolutional networks. Well, the results are not too good for now, but maybe in future we will use another approach to increase prediction or accuracy or precision. Maybe not use categorical, but only binary if its kids are adult. Also, we are using the crit search function to examine various combination of model parameters. Yeah, we have a graphic representation of CNN, DNN, and this is how we optimize the learning process. We have lots of optimizer. We changed also epochs and samples for iteration. For CNN, well, it's interesting that the best result is only with samples 32 and DNN 64. The result, while the CNN model achieved higher overall accuracy, it's not enough, I think, for now. But the problem is the imbalance of datasets still seems to play a role during the prediction. Maybe also we will working with specific dataset which we working on in with our students. We use some series, and we get audio from serials and labeling them. That's how old are the man on the audio or video, and save it to the CSV file. And thank you for your attention. Please don't hesitate. Raise your questions.
Thank you, colleague Renát, for very interesting presentation, and this is very interesting theme for conversation. And is there any question?
Hi, Grzegorz Madejski from Gdańsk University and Bioseco. I have a question about voice changers. I think you're familiar with the voice changing technology.
That's the problem.
And it's fairly developed. So I think you have to train the networks also to try to detect if the voice was changed. So this
will be our future work. And well, most of the time, the guys on the other side are a little bit dummy, so they don't know that there's something like synthesizer, and you can use machine learning to change it. But when somebody is very sophisticated, it's a very tough situation to detect this problem.
Yeah, the second question about implementation, because I think kids and children also often use apps that the parents don't use, so it's hard to cover. If you install it on Snapchat, they will go to TikTok. If you go to TikTok, they will go somewhere else.
Also, when I spoke with the teenagers, they told me that if you are using a Messenger, you are old.
Okay, yeah. So it's probably also a challenge for you.
Yes. So TikTok is for now the most. After that, Instagram. But TikTok, 30 seconds, something new.
Okay. Yeah. Okay. Thank you for your answer.
Thank you. Is there any other question? I had same question like colleague. And do you have any filter? Do you have any way to filtering devoted voices? Because predators always use distorted voices. Do you have any way to filtering this before this voice before analyzing the age of the predators?
This is the new project, and we already started, but we are trying figuring also this issue, that how it can be possible. Definitely, we need also some machine learning for detection and find some features that, okay, this is synthesizer, this is not synthesizer. Maybe this is the way how to will be possible to detect this problem issue.
Okay, thank you. Question? If you're not, thank you very much for your.
Thank you very much for your attention.
The next paper is paper entitled Evolution and Implementation of Electromagnetic Immunity, Electromagnetic Compatibility Compliance for a proposed power electronics based converter topologies for electric vehicles. Authors are Hakan, Tekin, Seyit, Vatansever, Davut, Ertekin from Türkiye. The presenter is Hakan, Tekin from Türkiye. You can explain.
Hello, I am Hakan. I completed my master's degree at Bursa Technical University, and I am currently working as an research electronics engineer. I will present our paper titled Evaluation and Implementation of EMI-EMC Compliance for a Proposed Power Electronic-Based Converter Topology for Electric Vehicles. My presentation will follow this sequence. I will try to keep it quite brief. Electric vehicles hold an important place in the transportation sector in terms of environmental sustainability and energy efficiency. Compared to internal combustion engine vehicles, they produce zero emission, reduction the carbon footprint, and accelerate the transition to renewable energy source by reducing dependence on fossil fuels. Advanced battery technologies such as lithium-ion batteries, which power electric vehicles, require high gain, efficient, and cost-effective DC-DC converters. These converters are used both to connect electric vehicle batteries to the grid and to meet the voltage requirements of various subsystems within the vehicle. In this study, the design, mathematical analysis, simulation, and laboratory result of a new and simple DC-DC boost converter based on a switch capacitor cell technology that use only a single power switch to connect electric vehicle batteries to the grid are presented. A power converter is generally expected to have the following feature: high efficiency, rapid response to load fluctuations, or low harmonic distortion in the output waveform. However, each type of boost converter has its own advantages and disadvantages, and the selection should align with the needs of the V2G system to ensure optimal performance. Switch capacitor-based converter offer significant advantages in electric vehicle application, providing high voltage gain, enhanced system efficiency with high power density and low energy losses. Their simple topology reduce component count and improves cost effective. Additionally, they provide galvanic isolation for safety, making switch capacitor-based converter crucial in integrated electric vehicles with the grid. The proposed boost converter is shown in figure 1. As can be seen, there is only one power switch in the proposed structure. This minimizes the complexity of the converter topology and the control circuit. In the first stage, the primary boost converter increases the battery voltage, and the switch capacitor cell further boosts the voltage capacitor to C2. Analyzing the operation principle of a switch converter requires examining two different time intervals when the switch is on and when the switch is off. Figure 2 shows the states of the converter's components during the switch on condition. By analyzing this operation condition, the voltage gain of the converter has been calculated. Gain is this is gain formula. Figure 2 clearly illustrates the gain of the proposed converter compared to the traditional boost converter. For instance, at the duty ratio of 0.5, the output voltage of the proposed converter is 5 times the input battery voltage, while the classic boost converters output is only 2 times the input voltage, which is a significant difference. Based on the simulation result for an output power of 200 watt, the total loss have been calculated and are shown in the figure 4. This figure clearly indicates that the dynamic and switching power losses of the diodes are the primary source of losses, followed by the inductor and switch. The efficiency diagram of the proposed converter, including both simulation and experimental test result, is presented in figure 5. This figure demonstrates that the converter achieves maximum efficiency at high power levels with efficiencies of approximately 97.8% for simulation, for 94.5% for experimental test result. Figure 6a shows the voltage values produced on the input battery pack side and the capacitor from C1 and C0 at the 0.5 duty cycle. Additionally, the voltage stresses across the switch and the diodes from D1 and D4 have been measured and presented in figure 6b. Another verification obtained from this figure is that when switch M is active, diodes D2 and D4 also become active, while diodes 1 and 3 are turned off, and vice versa. Furthermore, the current waveform for inductor L1 demonstrates that when switch M is active, a positive voltage is applied to inductor, indicating that is charging. A workbench was set up in the laboratory to test the prototype power converter. Figure 7 shows the hardware undergoing experimental test. Several practical measurements provided in this subsection. Figure 1 displays the gate source and drain source voltage of transistor M. The switching frequency is selected to be 25 kilohertz. This figure clearly demonstrates that when positive pulse reach the gate of the transistor. Figure 3 shows the input and output voltage for an input voltage of 49 volt, approximately 214 volt DC is obtained at the load side, confirming the correctness of the gain equation, which the most significant outcome of this study. An important consideration before applying the proposed converter to a battery pack is to check for EMI compliance. EMI is electromagnetic energy that varies from the interaction between devices or with their surroundings, which negatively affect system performance. With advancing technology, EMI has become a significant and growing form of environmental pollution. Therefore, conducting the necessary tests to ensure EMI compliance in the converter design of the grid importance. After confirming that our circuit operates correctly in the prototype test setup, we began the PCB design. In the PCB design process, we used the Altium Designer EMI rule checker tool to test EMI compliance. The software ensures the analysis by reviewing the 15 rules presented in the table. After reviewing the 15 rules, the software displays the causes of the errors and the areas where the errors are located, as shown in figures 10A and 10B. It also provides small tips for their solution. This program aims to approach an EMI compliant circuit design during the PCB design phase. This can protect use from long testing periods and high cost. The proposed converter features are preamplifier stage that easily doubles the voltage of the battery pack. The subsequent stage increases the preamplified voltage using only their diodes. The proposed study introduces a single switch power converter that enables the integration of an electric vehicle battery pack with the grid. Efficiency of 97.8% in simulation and 94.5% in experimental test has been achieved. Additionally, EMC filter design were implemented successfully to ensure compliance. This study was conducted as part of an industry university project development agreement established between Bursa Technical University, Technology Transfer Office, and Seger company. Thank you for listening to me. I am so sorry, very excited.
Thank you very much for your presentation. I like to say that this topic is very interesting. I'm very familiar with this because my student 2 weeks before defended the PhD thesis, similar topics, for example, vehicle to grid and influence on the environment.
Okay.
And is there any questions?
Thank you very much. It was very interesting. I have 2 short questions. One, you mentioned the standard, you check, the compatibility. What kind of standard did you use? This is the number 1 question. It should be a number, it's precisely determined all of the parameter, And as I saw, you only have put, a general where you test this, it precisely have to be managed. And the second, somewhere in the 3rd or 4th slide, you mentioned there is a difference between the theory and the real measurement. And I want to know, what is your opinion to what for the source, these big differences? Okay, if you go back, here, see? Efficiency diagram, real one and theoretical one. What is the difference? You should give me some hints.
These different component condition and environmental condition, maybe.
Is your analysis, you should know, the first percentage of the resistors or capacitors and so on. Because this is the stuff, when you get your PhD, you know the details, so it is not in the noise, it's not yet hidden. You really precisely went close to the subject matter. So sorry, I don't want to challenge you.
I don't know, sorry.
When you have a presentation and most likely you want to make some PhD degree in here, you not have the right to say, maybe I did something. I only want to support you too.
Okay,
there
thank
is nothing to do, but such kind of stuff, see, it's good, The only problem is you have here 80%, here it's 84, and also it's moving. And you have to read this condition, okay?
Okay, thank you.
And okay, if I were you, I have seen many presentations. If you go a few slides back, that more. Here, see? Oh, so. Better you have a block, all of the concrete. A lot of work. This one, see? This one.
Okay.
The problem is, if I am here, I'm an old professor, sorry, I only want to...
No.
This one, see the conclusion. If I read all of this one, why you are here? I immediately get impression like, you want to sell your product to me like a costumer, okay?
Okay.
So if you put, two, maximum 3 words, this is the 1, this is the 2, this is the...
Yeah.
And full stop,
Okay.
I only tell it to the next time, I'm
Okay. Thank you so much.
No, it's all of this one. And I have a lot of stuff, so I said, I have to read everything, it's boring.
Okay.
And also, my second or third was, the standard. If you put the standard, for the switches, there are plenty of standard, even commercial standard. You mentioned the companies, maybe it's here somewhere, and the company should know it because otherwise they not have a right to sell it. Or if they sell it, they could be punished. Sorry,
Okay. No. Thank you so much. Okay.
Thank you for a very interesting discussion. Is there any other question? I have one. When you say experimental results and the values obtained by experimental methods, what did you mean under name experimental results? How did you obtain these values? Experimental. Do you have any practical realization, or maybe use the electric or magnetic matter for measurement of the results, or only simulation and theoretical data? That's never mind. The same graphic as the professor before said. Experimental results. How did you get these results?
I'm sorry, but because my English is not good, I don't know.
I repeat. Experimental results.
Yeah.
Experimental values. You obtained these values. Do you understand? What method did you apply? How did you get these results, these values, those values? What did you use? Is there any
Grafiği nasıl
practical
hazırladım konusunu
realization?
soruyorum. I theoretical calculation and simulation calculation. Yeah.
What about experimental? You used simulation or
simulation is MATLAB, and theoretical calculation is mathematical formula.
Because I think that both of them is same source of data. Experimental means something different. I'm not sure, but the understanding.
Hadi devreyi mi anlatayım?
You use the electric and magnetic pattern for
Hocam çevirebilir misiniz? Sorry, I'm sorry.
Okay.
The experimental results, you use the laboratory work
Yeah,
branch,
yeah,
right?
yeah.
And how do you configure the laboratory work branch? Where is the formulas? Denklemlerle bu devre yazılmış değil mi?
Evet.
Okay. Thank you very much.
Thank you so much. I am sorry.
Thank you. The next paper is under title Logical Resonance in Izhikevich Neuron. The presenter is Vedat Burak.
Yes. Hello, everyone. I am the Zoom platform. Can you hear me properly?
Yes.
Thank you. My name is Vedat. I'm the research assistant at Erciyes University in Turkey. I'm going to describe a spatial scenario where an Izhikevich neuron acts as a logic gate and appropriate noise level. In the content of the presentation, as a relationship between nonlinear systems and noise, detail of the Izhikevich neuron, what logic gates inspired by the neurons have been made, and what are their shortcomings, resonance states of the Izhikevich neuron under optimum noise, and logic output of the single neuron at resonance, and also show the electrical coupling and chemical coupling with the logic operation. Finally, I will explain how reliable these logic operations are and how we determine this. I will explain the importance of our work by making a comparison with the other studies. Noise is an important factor in electronic circuit design and implementation platforms. The implementation platform must operate correctly under any circumstance. This noise becomes more important as the design of the platforms becomes smaller and power consumption decreases. Since noise can never be eliminated, it is important to understand the relationship between noise and nonlinear systems. Recent studies show that noise is not always detrimental. Under the appropriate noise intensity, the realization platform shows the greatest response. The noise we are talking about here in this paper the noise we are talking about this idea can be Gaussian, non-Gaussian, colored noise, or it can be a forcing current with the frequency and amplitude. In this study, in this paper, we use the forcing current as the noise source. Under the appropriate noise, the nonlinear systems can function as a logic element. There are already studies in literature with the bistable systems, two-well potential systems work as a logic element. However, the logic elements model created with the neurons are very few and they are inadequate. In this study, we have chosen a neuron model as a nonlinear systems, and this is the Izhikevich neuron model. Izhikevich neuron model have two differential equations and one resting formulation. Izhikevich neuron model have Izhikevich neuron can exhibit more than 20 of membrane dynamics. Unlike the Hodgkin, Huxley, Maurice Lecar, Wilson Cowan neuron models in the literature. And also you can see the 4 different dynamics in the Izhikevich neuron. The right side is the spike. We call that the spike. This one is regular spike, and this one is the fast spike. You can see the focused on the data. And the left side is burst dynamics. You can see the fast spike, but after the long resting state, another fast spike has been occurred. We call that the burst. The Izhikevich neuron shows any spike, burst, fast spike, or other dynamics. And yeah, so what does spike means and how does this spike occurs? It is important for us in this logic element. A neuron increases the potential by the receiving stimuli from the other neurons. If it exceeds a threshold level, just like this, the neuron produces a spike. The membrane potential is maximized and reaches the lowest again. If another stimuli from the neurons, the neuron show the spikes again. Recently, logic elements based on Hodgkin-Huxley Fitzhugh-Noguma neuron models have been developed, but in this works have some drawbacks. In the design a single neuron, logic inputs are need to collected. This current is logic input, and this is the other logic input. And also the neuron show the 3 input states. For the logic element with 2 inputs, we have to add 2 inputs or 3 inputs. This collection of the logic inputs brings the neuron closer to the threshold level. The neuron will generate spikes uncontrolled, and this will be reduce the reliability of the neuron's logic operation. And second drawback is that the membrane dynamics of these neuron models, Hodgkin-Huxley, Fitzhugh-Noguma, are quite limited. There is a very little diversity of the membrane dynamics compared to Izhikevich. Also, in this case, Hodgkin-Huxley neuron models has very complex structure. It's have 4 different equation, and it is really expensive for the implementation. Fitzhugh-Noguma neuron model is very simple, but the exponential term is hard to implement. And third drawback is that the single neuron is used in the majority of the studies. But logic processing circuits created with the network of 2 are quite limited. In fact, there are no studies that perform 3 input logic operation. Only electrical coupling network was used in the other works, but neurons also have connected each other with the chemical coupling. There are still deficiencies in the neuron logic element field. In addition, as I mentioned in the first drawback, the risk of undesirable increases input to currents due to additivity is prevented with the multiple neurons. Yes. Let's look at the mathematical expression of the Izhikevich neuron model in more details. First of all, we applied the simple bias current, and with this current, we choose the logic operation. If the bias current is 1, the neurons show logic OR operation, and if the bias current -1, neurons shows AND operation, logic AND operation. Logic currents refers to logic inputs, while we collect these currents in a single neuron for 2 states or 3 states of logic operation. But you can see the figures. We have to sum of logic inputs. But we applied these inputs to neurons separately in the neural system. 2 inputs neuron, we had to separate one input, just one neuron, second input, applied the second neuron. Is the same as the 3 inputs. The forcing current is required for the neuron to perform logic operation. We control the reliability of the logic operation with this current. In our study, we applied sinusoidal forcing current with the amplitude and angular frequency. Synapse current is 0 if the model is single, but if the synapses is electrical behavior, we use this formula, and G is the synaptic weight. If it is the synapse, it's chemically coupled, we use this formula. The key S is synaptic weight, and this equation is the chemical coupling. Logic operation with the truth table of two-stage logic element should be this table. If we choose the single neuron, we need to add these 2 inputs, and this amplitude is really low for the neurons. We need to sum of these 2, the -1, 0, and 1. And also we can choose the single neuron. We show that separately. In this figure, this one is the input 1, logic input, and the logic second input. And this is sum of these 2 inputs. Also, you can see that these 2 inputs with the logic 1 and logic 0. And we also show that the Izhikevich neuron show the 3 inputs logic elements. Same as situation in here, we add these 3 inputs, and we have 4 different states. And also, we apply the separately 3 inputs current with the 3 neurons. And for the truth table. Let's see what kind of the results we get with a single neuron. For a logical operation with 2 inputs, figure A shows the AND operation, and figure B shows the OR operation. These 5 different dynamics, we want to show that the Izhikevich neuron had reach dynamics. Phase spike, tonic spiking, spike latency, mixed mode, and regular spike. We have obtained a 3-state signal, just this and this one. According to value of the bias current, the Izhikevich neuron performs a logic operation and or. The spikes you see here, the ones we don't actually want. We don't want to these spikes. We want to this one, because for the AND operation, it only needs to exhibit membrane dynamics for the state 1, 1. But here you can also OR operation in this study. This is the second figure. We keep the angular frequency, these 2 type of figure. Constant, angular frequency is constant. Amplitude has been changed. These numbers is optimum value with the amplitude. As we move away from these values, the reliability of the logic element has been decreased. And also you can see that the 3 inputs logic operation. As you can see, unwanted spikes are a bit more depending on the membrane dynamics, but this is acceptable because the reliability is above the 19%, and this is the level. And also show that the electrical coupling same membrane dynamics and operation or operation. Here we apply the separately logic currents, and this is the synaptic currents also. You can show the focus to this one. We have two neurons. Also show that the two outputs, but these outputs get strong synchrony behavior. You can see that these focus details. And also we expect the neuron to produce spikes at logic 1 in accordance with the truth table. And as the same as the three inputs, the Izhikevich neuron with three neurons shows the logic and or operation. Yes, we have some unwanted spikes, but the reliability is really high. I want to show that in the next papers. We, with our work, the logic processing capability of the neural systems has been demonstrated for the first time. As you can see here, undesired spikes are significantly reduced with the chemical coupling. It was able to perform logic operation with the chemical coupling. It is the same as the three inputs, but unwanted spikes is high, but also synchronization is not as strong as the others, although this keeps and reliability above the sufficient level. Okay, how do we calculate this reliability? The reliability of the logic element is directly related to how accurate the output is according to input diversity. Here, NSR represent the number of correct results. These are correct results, and these. NR represents the number of all spikes with the same tree. If all results are the accordance with the truth table, we can say that the reliability is 1. If none of them is 0. It is about how accurate the logic gate is with respect to large number of inputs. Given that the inputs here are 1,250 different possibilities, we can calculate the reliability of the Izhikevich neuron with the fairly high probability. In this, you can see the reliability of the single neuron. These two figures, the angular frequency is fixed, but amplitude of the forcing current is changed. Optimum value of the amplitude that neurons show strong reliability, big reliability, logic elements, but the amplitude is not sufficient level. It is reliability is really low, and also you can see the another reliability diagram. In these two figures, we fixed the amplitude, but the angular frequency changed. You can see the some maximum point with the diagram. And electrical coupling with the Izhikevich neuron, we used this current, and G is the synaptic weight. Also, same as the single neuron, you can see the different reliability diagram. I want to say that another two diagram is synaptic weight. When it is below the sufficient level, we cannot speak of the reliability. But with the strong synaptic weight, the high reliability logic operation can be achieved with the electrical coupling neural system. And also chemical coupling, you can see the same similar diagram, not same, similar diagram with the chemical coupling, optimum angular frequency and amplitude. We used this formula with the chemical coupling, K as the synaptic weight in this formula. We choose the K as very carefully, because in varying amplitude and angular frequency, Izhikevich performs reliable logic element. The synaptic weight also important for the chemical coupling. And the last slide is differences and advantages of our work in overview. In the black background, and this one is bistable and systems, nonlinear systems, and two-well potential nonlinear systems. Perform two-state logic. There are no three states. And also single dynamics. The dynamics diversity is really low. Yes, they show some network systems, but these network systems just have electrical coupling. Some of the works here as network capability in the logic processing capabilities of the neuron models are very new subject, and their capabilities have been demonstrated this type. The neural network also insufficient in here, just one, and also this is just electrical coupling, and they are not show the three inputs. But unlike the other studies, we show that simple structure neuron models can perform both two-state logic and three-state logic operation with both electrical coupling and chemical coupling. And also our work have 5 different dynamics get the logic operation. And thank you for listening for me. I will be happy to answer your question.
Thank you. I would like to say thank you for your presentation. Is there any question from audience? Yes or not? No, okay. I have one question. The reliability of your proposed model, the same at all frequencies or not? Is this
No, it is not the same all frequencies, because we need to find the optimum value with the frequencies and amplitude. The reliability is really low this scale. And this is not the same. This is the differences from each other. But all of them above the 9%. We have to focus on the 9%.
Okay. Thank you.
Thank you so much.
Any other question? If you're not, thank you again.
Thank you so much.
The next paper is Pistachio classification based on acoustic systems and machine learning. Presenter is Yavuz, Türkiye. The authors are Yavuz, Türkiye, Zeki, Seyma. Is it right or not? Seyma. Okay, thank you. Oh.
My name is Yavuz Türkay from Turkey. I'm working Sivas Cumhuriyet University, Electrical and Electronic Engineering. Pistachio classification based on acoustic system and machine learning. My working. Outline, introduction, objectives, methodology, data analysis, results, and summary. Shortly. Pistachio nutritional content of and history. Pistachio is a hard shield fruit known for its high nutritional value. It has a long history and is popular fruit worldwide. Growing area and producers. It's grown between latitude 30 degree and 45 degree in region with hot and dry summers and cold and rainy winters. Iran, the United States, and Turkey are the leading countries in pistachio producing and hold a large share of the world pistachio market. Processing and quality control. Processing, marketing, and storage of pistachio is critical process. Mechanical, acoustic, and optical technology are used instead of traditional methods. Machine learning algorithms offer great potential in the classification and quality determination of pistachio. Objectives: developing innovative and cost-effective method, identifying open-shell pistachios with acoustic emission sounds, avoiding unnecessary material and expensive sensors, applying Hamming window and elimination noise, processing of signals and feature extraction, classification of feature with SVM, testing accuracy rates. Mel frequency capture coefficients. From the audio recording obtained from the microphone, we will extract the feature of the sound using MFCC. These features will be used to classify the sound. As shown in figure, MFC coefficients are obtained through a four-stage process. The signals captured from the microphone is proceed in the first stage. This stage includes operations such as a pre-emphasize, framing, and windowing. Pre-emphasizes as a filter that limits low frequencies is applied to the signal recorded with the microphone. Framing is a technique used in audio processing and analysis. This process involved dividing a continuous audio signal into specific time intervals, allowing for separate analysis of each frame. Windowing is a technique used in the field of audio processing and signal analysis. This process involves multiplying segments of signal obtained with specific time interval by the window function to reduce edge effects. These methods provides frequency information about a signal by transform its form time domain into spectral components in the frequency domain. In this here, for open shell pistachio time domain signals, this for closed shell pistachio time domain signal. In this here, open shell frequency domain signal, closed shell frequency domain signal. The signals generated by impact open and closed shell pistachio on a plate analyzed in both the time and frequency domains. While the time domain signals show no significant difference between open and closed shell pistachios. Clear distances are observed in their power spectra, which can be used for effective classification. This is Mel filter banks. Filter banks which are widely used in speech recognition applications, are typically configured based on the MEL scale. Non-linear frequency. The figure shows triangular filter banks placed on linear frequency scale using a 24-band non-uniform filter banks. Other block is capstrum. The capstral representation of audio or acoustic signals best capture the local spectral characteristic of the signal in specific frequency range. This capstral representation is typically obtained through a process called capstrum. As shown in the figure, the capstrum calculation process consists of 3 main steps: discrete Fourier transform, logarithmic operation, and inverse discrete Fourier transform. Support vector machines are machine learning model developed by Grooming and others, used for classification and regression analysis. The primary of SVM is the separate data points according to their classes or to create a decision boundary. The best distinguishes between them. The model projects input vectors into a high-dimensional feature space and aim to find a linear decision boundary that accurately represents the minimum distance between the points in this space. Support vector machine can encounter 2 different scenarios, depends on whether the data is linearly separable or not in the sphere. The figure shows that although there are many possible planes between 2 classes, only one minimizes the margin between them. The SVM classifier identifies the optional hyperplane that maximizes the margin between the separating hyperplane and nearest training example. The need for classification in the Pistachio cultivation. One of the major issues encountered in Pistachio cultivation is that some Pistachio have a closed shells. This is a factor that directly affects the quality and marketability of the product. Closed shell Pistachios are not preferred by a consumer because they are difficult to access, whereas open shell Pistachios offer a significant marketing advantage as they are ready for consumption. Figure shows a visual representation of open and closed shell Pistachios. This is experimental setup. Experimental setup is a 6 parts. First part is styrofoam box for noisy. Second, the interval where the Pistachio are placed in the sphere manually. This is the metal plate. Third part. Microphone, 4th part. Laptop, sample storage box. This is here. Experimental process. Pistachios dropped from the designed slot in the experimental step produce sound upon impact with the metal plate. This sound is captured using carbon microphone and recorded on a laptop with the help of MATLAB analog input recorder. The recorded signal are then stored separately for open and closed shell Pistachio's. Future extraction was achieved using MFCC for recorded sound signal of open and closed Pistachio's. Pistachio classification was determined with SVM. The best classification model is developed using Bayesian optimization process. Bayesian optimization is a powerful method used to optimize the hyperparameter of machine learning models. In this process, different combinations of the hyperparameters are evaluated to determine the best performing model. Figure shows the minimum objective function value and number of the functions. This graph shows how the objective function changes during the optimization process and how many different combinations are evaluated to get best results. The minimum objective refers to hyperparameter setting that minimize the classification loss. The graph shows how the objective function improves and reaches the minimum value at each step of optimization process. In this process, many different combinations of hyperparameters were tested to find the best performing settings. This figure shows the observed minimum objective value and the minimum objective value that provides best prediction. The graph shows the relationship between the minimum objective function value obtained during the optimization process and prediction model that provides this value. The minimum observed objective value represents the lowest loss value obtained at the end of the optimization process. This value matches the minimum objective that provides the best prediction and achieves less classification loss. This classification parameters, kernel function, radial basis function, box constraint, kernel scale, cross-validation error, this is important, number of input data, open shells and closed shells. Number of output data, 1, open shells or closed shells. Number of training data, 80. Number of test data, 20. Table gives the parameters and statistical information of the SVM model. Here the cross-validation error, in this here, error rate shows that the model performs well on the data set and has high generalization ability. In the study, the classification each sample was performed 40 times to avoid the classification process being affected by randomness. These repetitions were done to improve the accuracy and the reliability of the model. By repeating the classification process for each Pistachio sample, the effect of the different variation and possible noise is minimized, resulting in more consistent results. This was an important step to improve generalization capability and classification success of model. Results and summary. Innovation system proposal. In this study, an innovative system is proposed for detection of open and closed shell Pistachios using a combination of MFCC and SVM. Open shell Pistachios were detected with an accuracy rate of 97.2%, while closed-shell Pistachios were detected with an accuracy rate of 97.95%. Simple and cost-effective solution. The system provides highly accurate classification using only a carbon microphone and MATLAB without requiring additional equipment. Improvement in quality control and production efficiency. The proposed method has the potential to improve quality control process and increase production efficiency in the agriculture and food industry. Suitable for industrial applications. With its simple structure and cost effectiveness, the system is suitable for widespread use in industrial applications. Important step for automated classification and quality control. These results represent an important step towards automating product classification process and improving quality control in the agriculture sector. Thank you very much.
Dear colleague, thank you for your presentation. Is there any questions from the audience?
You already mentioned that it's appropriate for industry, but how? Because you tested the Pistachio one by one, yeah? That's correct.
Yes, one.
And when
Only industrial application is not. Maybe improve.
Okay.
It's okay?
Yeah, thank you.
Okay. Any other question? Okay.
You mentioned that for the training, the model, you repeated each one of the pistachios 40 times, right?
Yes.
Okay. And then on the 20 samples for test, to measure the accuracy with unknown data, it was also done 40 times or just one for the test?
No. Yeah, I don't understand.
First, you
Repeat
train the
again?
model, right? And then we have the 20
Yes.
unknown pistachios
Yes.
for testing the accuracy. On these unknown pistachios, were it just measured once, or you took the average of the 40 to know the accuracy? 40 times each one.
And then model for the testing process. And then model testing process for 40 times repeated. Is it okay?
Yes, and to test it, the result would be the average of these 40 results?
Yes, average. Yes, average. 40 test, average. Is it okay?
Thank you.
Thank you. Other questions? I have one question. What data were used as a training vectors when you in implementation of machine learning? I saw some values, but what data for training vector, the input vector you used to compare with results? Because you say that 97.
I will compare neural networks and other
data.
Microphone.
Okay.
Repeat again.
Sorry.
Microphone is a good good
Result.
is not good. Is not good because noisy. We have a noise in this in working place.
That means that results from microphone is training vectors for implementation of machine learning method.
No,
Machine learning.
no. Microphone sound signals in the microphone sound signals. Firstly, MFCC, mel frekans capsural.
Okay, that's okay. That means that this is that's there are introduction or training vector data. Okay, that's okay. I
Vector
understand now.
data, MFCC.
MST, yes. Thank you very much. Any other question? Thank you very much for the
You're welcome.
presentation. And last paper. So what is the difference in buffered amplifier realization using 32 nanometers FinFET technology and universal filter applications? Authors are Sardar Altan, Mustafa Konal, and Firat Kacer. Presenter is Mustafa Konal.
Yes. Hello, everyone. My name is Mustafa Konal from Tekirdağ Namık Kemal University in Türkiye, and I'm an assistant professor in the Department of Electrical and Electronics Engineering, and I'll present voltage differentiating buffered amplifier realization using 32 nanometer FinFET technology and universal filter applications. The outline of my presentation will be first introduction, then FinFET and VDBA, and realization of VDBA-based filter circuits, simulation results, and conclusions. Why new generation transistors? As technology improves, more transistors must be placed in the same silicon area. So to accommodate more transistors, the length of the transistor channel must be reduced. So this dimension has been reduced from the past to the present, and the length of the transistor has been reduced to nano dimensions. However, short channel effects have recently pushed the limits of phasings and engineering to the point where smaller transistors are no longer feasible, and conventional CMOS technology has reached its physical limits. So on this reason, Moore's law has become challenging to sustain, and the focus has shifted to improving transistor efficiency and exploring new materials and elements. So changing the manufacturing material is too expensive. New generation transistors are very important for today's technology. Here is the short channel effects, and FinFET technology is a new promising alternative to CMOS technology to overcome the issues caused by the reduced transistor size. FinFET offers some advantages over CMOS, like including reduced short channel effects, higher drain current, and reduced static leakage current, faster switching time, low power consumption, and also lower supply voltage. Active filters are the basic building blocks of analog signal processing application. A lot of different active elements can be used to realize filters, such as first and second generation current conveyors and current differencing transconductance amplifiers, current differencing buffered amplifiers, differential voltage current conveyors, and VDBA also, and etc. VDBA has high and low output impedance. The input of the VDBA is similar to operational amplifiers, has differential input structure, but no need for an additional input resistor. So other advantages compared to op-amp, VDBA has higher bandwidth and provide lower power consumption. As I talk about VDBA, the electrical symbol of the VDBA is given in figure 1, and it has a differential voltage input and current output, and the Vz is equal to Vw, so the Z terminal has high impedance and the W terminal has low impedance. So the terminal relationship of a VDBA is given in matrix form. Here the GM is the transconductance of the VDBA, and alpha is the ratio of VW to VZ. So it's equal to 1 minus epsilon V. So epsilon V is the tracking error. So alpha is approximately 1, equal to 1. Here is the implementation of the VDBA based on the FinFETs, and the first stage is an operational transconductance amplifier, and the second stage is a voltage buffer. So the voltage buffer provides the impedance matching. So just here I forget the W terminal should be here. I noticed that. No. Here. Yeah, the W terminal should be here. I noticed that I forget the row. So here is the operational transconductance amplifier, and here is the voltage power for impedance matching. The filter realization based on the VDBA, and also VDBA is based on the FinFETs. I said the advantage is there is no external resistor, so 2 VDBA, 2 passive capacitors, and there is a universal filter, 3 inputs and single output. So we can obtain 5 different filter structures: low pass filter, high pass filter, band pass filter, band reject filter, and also all pass filters. And here is the output voltage transfer function of the circuit. If you apply the input voltage to different terminals, you can obtain the different filters. For example, if you apply the input signal to V1, and V2 and V3 grounded, low pass filter, and the others like this. Simulation results. The dimensions of the transistors are chosen as given in table 2. Here we used LT-SPICE to simulate the FinFET VDBA and also the filter structure using 32 nanometer FinFET technology parameters. And we chosen the supply voltages as 0.2 volt, and biasing current and biasing voltage of the circuit is chosen as 13 microampere and minus 0.11 volt respectively. Simulation results for the VDBA. The DC characteristics of the input stage of VDBA is given in figure 4. Here the characteristic is symmetrically set to respect to 0, and the DC characteristic of output stage of the VDBA, and here we can say the ratio of the VW and VZ is alpha, so it's approximately equal to 1. Also, we simulated the AC characteristic of the VDBA. The figure 6 shows the transconductance gain of the VDBA. Here is the dB measure, and in linear, the value of the transconductance is measured as 136 microsiemens. And also the AC characteristics of the output stage of the VDBA. Here again, the ratio of the VW to VZ, so alpha is 1, about up to 200 megahertz. And the simulation results for the filter realization. Band pass filter, high pass filter, low pass filter, and band reject filter gain frequency responses are given in the figure 8, and also gain phase and also phase frequency, gain frequency and phase frequency graph of the all pass filter is given in figure 9. And in order to test the filter, we apply sinusoidal signals to bandpass filter, the amplitude of about 40 millivolt peak to peak, and the input and output signals time response is given in figure 10, and the total harmonic distortion of the bandpass filter we obtain and given in figure 11, and we demonstrate that up to 100 millivolt it's acceptable limits, the total harmonic distortion of the circuit. And we compare the performance parameters of CMOS-based VDBA and FinFET-based VDBA. So FinFET-based VDBA comparing to CMOS-based VDBA, the bandwidth is very large. And for the filters, the frequencies are higher, And also supply voltage, we use 0.2 volts for FinFET based VDBA, and CMOS based VDBA, it's 1.5 and 2. Here is 0.2 volts also, and this study used the DTMOS, dynamic threshold FET based VDBA. And also we compared the performance parameter of FinFET based OTA, because in the literature there is no FinFET based VDBA. There were some FinFET based operational transcontiguous amplifiers. So we compared the first stage of our VDBA was operational transcontiguous amplifier. So we compared the first stage of our circuit with the other FinFET based transcontiguous amplifiers. And again, bandwidth and transconductance we obtained are good, and power consumption is 10 microwatt for our study. I mentioned conclusions the last stage. So as a conclusion, I can say that for our study, the VDBA, FinFET based VDBA is advantageous for low power consumption, also wide bandwidth, and also I mentioned again the operational transcontiguous amplifier stage of our circuit is demonstrated good results when compared to the literature. So here is my references. Thank you very much for your attention and listening. If you have any question, I can answer.
I want to praise your presentation, and I want to ask auditorium to ask something about this paper, any question. If you're not, that was the last paper, the last presentation, and I want to close our session. Thank you very much.
Thank you.